Hello everyone. I hope you all are very well. Welcome back in the part 3 lecture series of the distribution of ocean and continents. I hope you have watched the videos of part 1 and 2, because without part 1 and 2 it will be difficult for you to understand part 3 videos. So my suggestion is to you that please visit part 1 and 2 video, then you will start this part 3 video. So today's discussion we will start with by showing you a small video. This video I have shown you earlier also, the animation, but just to recapitulate that what we have done in our previous lecture. So with this small animation, all the facts and ideas, I hope you can recall that yes, these things are happening inside the earth. So as the same process, you can see the convectional movement, the circulation in the mantle layer, we can see. Okay, the magma used to circulate because the magma is getting warmed up near the core. The magma near the core is getting heated up. So what is the nature? When a material is get heated up, it becomes lighter. It will start moving up. So it will, when it will move upward, there is ocean water is there. It will cool the magma that beneath the basin. It will cool it down. Again the cooler magma will come in the core, just above the core. This circulation is very much fascinating, and with this circulation, I've told you an example on that day before also, that if you try to move a table, a huge table, it is very difficult to move a table. But if a table consists of wheels, it is very easy to move because it creating circulation. Okay, you are applying force, it is creating circulation. So the same thing as our continent, as our plates, we will later on study the concept of plate tectonics. So these are plates, ocean basins, continents, they used to flow in a semi-solid structure. So this semi-solid structure is moving, and with this movement our continents sometimes collides, they sometimes move parallelly, and there are a lot of different movement we can see. Okay, so if I consider this image again, so this gap you can see it is a ridge. Okay, it is dividing two different basins or two different continents or two different plate, whatever it is. Okay, but it is a separation. This is known as a ridge. Okay, this is known as a ridge, and a ridge has a very, it has a depth. For example, Mariana Trench, the depth you have seen, a v-shaped depth. One side you have one continental plate, another side you have another continental plate, and there is a depth. Okay, that is a trench or a ridge. Okay, so these circulation, it's very much prominent we used to see. This is a rollback technique, because when the continents move inside or the plate move inside, due to heavy energy, heavy heat, they start melting down. Again they used to come up, and the magma started flowing in that part, and from the ridge the magma started exploding. It forms in lava, and when the lava comes out, it solidifies. Like this way, every day we used to lose continent, and every day we used to get continent. That is a basic phenomena in geomorphology and geology. Okay, so these phenomena used to takes place, and like this we have seen the concept of ocean floor configuration in our previous classes. So that is known as subduction, because the plate in your right hand side, it is moving inside the plate of your left hand side, and you can see a little bit mountainous structure. So when this right hand side plate will go beneath the left hand side plate, it will push the left hand side plate, and what will happen, magma chamber will form beneath this mountain. Okay, magma chamber will fall beneath this mountain, and the magma started, they used to get a zone there, and magma used to consider here, and with a series of pressure, continuous series of pressure, it will make its own chamber to move out. And like this way, what will happen, after a few years, it will explode like a volcanic eruption that we have studied in volcanoes chapter. Okay, so that's all about a general discussion of the concept of ocean floor. Welcome you in this lecture session, the distribution of ocean and continent. Today we will learn the concept of sea floor spreading. Concept of sea floor spreading, part 3. Myself, Pratik Chakraborty. Let's begin our journey. Concept of sea floor spreading, particularly the mapping of the ocean floor and paleomagnetic study of rock form, oceanic region reveal the following facts. What is paleomagnetic? Paleo means old. Magnetic, you know what is magnetic. So old magnetic, we have to know the how our earth was before. Is there is magnetism present? How we can find out? So if we study rock, there is different techniques of studying rocks. So each and every rock most probably consists of magnetic properties. It varies, but consists of magnetic properties based on their ages. Okay, so if we can study the magnetic properties, we can easily understood the concept of the magnetism that was there in previous time. It was realized that all along the mid-oceanic ridge, volcanic eruptions are common, and they bring huge amount of lava to the surface in this area. That means what? In this mid-oceanic ridges, volcanic eruption used to take place. We have studied about the concept of Pacific Ring of Fire. Okay, so please revisit the video in part 1. They bring huge amount of lava. Hawaiian is an example because Hawaii island falls under the Pacific Ring of Fire, and each and every day Hawaiian island used to recreate it itself. Okay, the rocks equidistant on either side of the crest of mid-oceanic ridge show remarkable similarity. That means if I consider a mid-oceanic ridge, for example Atlantic ridge, if I consider, so if I take the Europe and Africa, the rocks, and North America, South America, they will show similarities in terms of the period of formation, chemical composition, and magnetic properties. Rock closer to the mid-oceanic ridge have normal polarity and are the youngest. The age of the rocks increase as one moves away from the crest. So from the crest, if the rock is moving away from the crest, the age of the rock increases. See what happens from the ridge. You just imagine the ridge. So from the ridge, what is happening? The continental margin, the oceanic basin is forming. So it is not forming in a same way. Okay, it is not forming in that in a frequency. It will form, it will stop, it will form, it will stop. So this pause, normal reverse, this is a technique. It will stop, it will again pushed forward, again it will stop, again it will pushed backward. So this dynamism used to follow, and each and every dynamism at that time when the rocks are forming at different ages we used to see. The ocean crust rocks are much younger than the continental rocks. The oceanic rocks are much younger. The age of rock in the oceanic crust is now here more than 200 million years old. Some of the continental rock formation are as old as 3200 million years. So if you just take a rock from the ocean and if you just take a rock from continent, the differentiation of the age you can see. So from that differentiation of the age, it is very clear that oceanic floor is very young. It is not only very young, but it is still spreading in a rapid rate. It's forming in itself. This is the diagram, the cross sectional, the diagram. You can see the 2D diamond, that what is going on inside there. The same diagram I have showed you in the part 2 lecture series. So here you can see the same process, that sometime it moving in a two different direction, that is diverging. Okay, they are diverging, and the ridge is getting more and more bigger. When the ridge is getting more and more bigger, the magma comes out in form of lava and it spread. But many a times what happened, they comes closure, converging. They shows a property of converging. Here you can see the continent is moving this side. Okay, but the ocean basin is moving that side, and this fine line is the trench, the formation of trench. Mariana Trench is an example of such kind of formation. So this is the inside story, what you can see, that how our oceanic floor is spreading, in what rate and in what frequency. This is the video again, just have a look. Third time I'm showing this video, please revise it, because these video consist of all the information that you need. Okay, the ridge you can see, it is moving like this, divergent way. It is moving in a divergent, they're not coming closer, they're moving like this. So what is happening? They're moving, okay, continuously they're moving, but when they're moving inside, they again go below, they melt and they again come out. That I used to say that it is convection. Okay, and here you can say different rock forming ages. Okay, Concept of seafloor spreading. The sediment on the ocean floor are unexpectedly very thin. The sediment on the ocean floor are unexpectedly very thin. Scientists were expecting, if the ocean floors were as old as the continent, to have a complete sequence of sediment for a period of much longer duration. However, nowhere was the sediment column found to be older than 200 million years. That means this is another proof we have that the thinnest part, ocean, is very thinner. So one suggestion is that, we have seen the concept of drilling project till 12 kilometer, 10 kilometer we have drilled inside the earth. So if I start drilling in the ocean basin, the work will be more easier, so we can go much deeper, but we don't know the consequences what will happen, but the idea we can use it, because the ocean basins are much very thin, it is very thinner. The deep trenches have deep seated earthquake occurrences, while in the mid oceanic ridge areas the quake foci have shallow depth. Okay, so this term we will not understand now. In the geomorphic process chapter, we will definitely decode this statement. Okay, particularly what this statement means, that in the trenches means when the continent and ocean basin meets, or the two continent meets. Okay, at that area earthquake occurrence is very frequent, but in the ridges area, as the ridges, they have a ridge, they are showing ridges because magma is coming out slowly, they're building the oceanic basin. So there you can see the shallow depth of the uh, of these trenches and all. These facts and a detailed analysis of magnetic properties of the rock on either side of the mid-oceanic ridge led by Hess 1961 to propose his hypothesis known as sea floor spreading. So who postulated this hypothesis? Sea floor spreading, that is Hess. Hess argued that constant eruption at the crest of the ocean ridge caused the rupture of the oceanic crust and the new lava wedges into it, pushing the oceanic crust on the either side. The ocean floor thus spread. The diagram you have seen, the same thing is written here. Okay, but the word is little difficult. The NCERT word is little bit like that. Okay, so this thing is very clear that finally we have a proof. Yes, our sea floor is spreading. This is an example again. I would like to show you that the younger age of the ocean crust, as well as the fact that the spreading of one ocean does not cause the shrinking of the other. This is very important thing. Okay, the spreading of one ocean does not cause shrinking of the other ocean, but in continent, the spreading of one continent can shrink another continent. For example, Indian plate is shrinking, it is submerging inside the Eurasian plate. Okay, um, causes the shrinking of the other, made Hess think about the consumption of the oceanic crust. He further maintained that the ocean floor that gets pushed due to volcanic eruption at the crest sinks down at the oceanic trench and get consumed. That means the trench that you see, it is actually the oceanic basin, the limit of oceanic basin or the oceanic crest that is going on, and again it will reform based on the spreading. Okay, so these ideas are a little bit very much scientific, very much geological based. So in a more simpler way, I think you have understood the concept of what is going on inside the ocean, how it is spreading, how the convectional current are important, how rollback is going on, and what is the concept of ridge. Okay, next part we are moving is the concept of sea floor spreading. This is the concept mid oceanic ridge. You can see this is known as divergent movement because the two parts are diverging from both the sides. Okay, they are diverging. So that is an example, the magma chamber you can see. So that the different layers you can see, okay, of rock and all. So normal, and this is normal. Okay, this one lined structure is normal, but these between these are the reverse. So why these are reverse? There is a very good explanation of this. See, I have told you that when the ridges, when the ocean basin is forming, when the magma is coming out, it is depositing in the ridges and the basin is forming. At that time, constantly it will not form, it will pause. It will pause, many times it go reverse. because convection and circulation is going on the other side it can push the plate or the basin to again subsidize in the ridge. So these movement of normal and reverse we can see, but in reality it is impossible to visit. In reality it is impossible to see. Okay, these are all based on theories and concept. Okay, that yes, these things are happening. So different types of rock aging formation we can see, but this is in the case of ocean formation, but ocean basin formation. But if I say you that how continents will move, in this example you can see the same process. Continental rifting is going on as mid oceanic ridge is going on at that video. So spreading of continent is going on, breaking, foliation, okay, breaking of this uh, lineage breaking is going on. So the mid oceanic ridge ocean basin is open here at that time. Okay, so what will happen after this? So two continents are spreading apart. So after spreading, what is going on? The right hand side continent is moving towards the left hand side continent, and it is known as subduction. And these create what? Contraction in the ocean basin. That is, it's compressing the ocean basin. So when the ocean basin is compressed, what will happen? On the left hand side, the landforms will rise up. Okay, folding will take place, and finally when the right hand side continent will collide with the left hand side continent collision, we can say this kind of volcanic mountains will emerge, or any kind of fault mountain will emerge. That is a story of collision. Okay, so I hope finally seafloor spreading concept is clear to you. uh, Before concluding this portion, one thing we have there, that is the concept of plate tectonics. In the next part 4 video, the last video of this chapter, will be of plate tectonics. Plate tectonics, what is a plate tectonics? Since the advancement of the concept of sea floor spreading, the interest in the problem of distribution of ocean and continents was revived. Before that, what we used to say that no continent, Pangea was there, that's all. There is ocean doesn't have any kind of basin or any kind of subsidizing anything, there is nothing. So but later on, when we started distinguishing that no, continent having this kind of parameters and ocean having this kind of parameter, we have two different concepts. So before this we have studied only ocean, that is configuration of ocean floor, sea floor spreading, only these things. Next class we will study the concept of plate tectonics. It was in 1967 Mackenzie and Parker and also Morgan independently collected the available ideas and came out with another concept termed as plate tectonics. A tectonic plate, also called lithospheric plate. A tectonic plate is also called a lithospheric plate. It is a massive, irregularly shaped slab of solid rock, generally composed of both continent and ocean lithosphere. So in our next class, we will reveal that how our plates are there. In the right hand side, you can see a map, a division, you can see cracks are there in the map. So is our plate look like this, or because we have imagined our continent as a geoid, normally a shape of the earth is a geoid. So in reality, is this things can be visible? What are the different types of plate? Which plates is vulnerable? These concepts we will study in our next chapter of plate tectonics. Thank you everyone. Take care, and please revise the concept of convection theory and all the videos, because these videos are very interesting. If you go only by books, you will not understand anything. Please refer the video and animation. By seeing the animation, it's my guarantee that all the ideas will be clear. At least you have a concept. After that, all the technical part, that is rollback, subduction, abduction, ridges, you have to study from the book, but the base conception will be clear from these videos. Okay, thank you everyone. Thank you for your time and consideration. We'll meet in the